quick sailor stories, we call it, Swedish sailor stories, learnings and experience from Swedish actors in the maritime field. So first, Seb Corby from Safety Tech Accelerator will present, and then we'll hear from Staffan and the sailors. I don't know if you're all sailors, but we'll see. It will be Jenny Folkunge from the Port of Trelleborg, Dan Erik Andersson from the Port of Gothenburg, and Christian Andersson from Öresundslinjen. Then we'll follow a session after another fika, of course, with presentations. Very exciting lessons learned from the ship fire investigation of the Stena Scandica that was on fire not too long ago outside the coast of Gotland. Then Claes Möller from Tank will present employee-based dialogue from a safety perspective, more on the soft and organizational side. So that's also exciting. And finally, before the panel discussion, this mass code, what's all that about? The future, I guess. CFIS Papa Giorgio from the Norwegian Maritime Authority will present on that. He's actually coordinating that group at IMO, so that will be exciting to hear about. The panel discussion about detection on fires on board, challenges and possibilities. We're definitely seeing new challenges with new fuels, new types of cargo, but we also have the traditional challenges, or if you can say so, where we see a lot of fires in engines still, for example, and the charcoal. Come on, why hasn't that been solved? So a lot of challenges, and we're here to try to solve them together, right? So let's move on with the first speaker of this afternoon, Seb Corby. You're welcome to the stage. Oh, technical.
We are looking for one piece of this microphone. So if any of you old speakers have it still in your pocket, that would be. This is working, but for the other group, maybe you have it. Okay.
Just checking this is working.
Nope, just.
Testing. Ah, that sounds like it's working. Thank you for having me here. I think it's commonly called the graveyard shift, isn't it? After lunch, everyone's digesting their carbohydrates and struggling to concentrate. So I'm talking about accelerating innovation in maritime. I do this in maritime, construction, any kind of safety critical industries, as they call it. My name is Seb Corby. I'm a principal consultant at Safety Tech Accelerator. Some of you may have heard of us. Many of you, this might be the first interaction, so I'm going to do the terrible thing and introduce who we are and do a very, very short sales. We were established by Lloyd's Register. I'd have thought most of you do know who they are. Very old business, starting a very new business. One of the oldest companies in marine, wanting to create an organization that's looking at the bleeding edge of technology. I think it's a good idea. I chose to work there, but it's a really interesting hybrid with both us and LR. Our job is to help people invest in technology. It's pretty difficult. There's a lot of stuff out there. Not all of it works. All of it's pretty difficult to implement. Our mission is enabling organizations to really make the most of emerging technologies. And we do this across different industries and different technologies. We cover, I've already said that, we cover all industries. And we're trusted by lots of people to do this. We've only been around for a few years, but we've got some big names on our website, and we're very proud of that. But here's the crux of it. What I'm here to talk about, for the most part, is a program that we're running called Cargo Fires and Loss Innovation Initiative. We tend to call stuff what it is, Safety Tech Accelerator, Cargo Fires and Loss. We don't come up with fancy names. That's not really our jam. This is a collaborative innovation program across maritime. All of you are going to recognize those drivers. We know about the issue of cargo fires and loss. I don't need to tell you about that. But the interesting new element to this is that there's lots of interesting technology that maybe wasn't even around 5 years ago, or maybe it was around 5 years ago but wasn't particularly useful, we're now at this point where there's lots of stuff on the market that could solve our problems, but it's quite difficult to work out exactly which vendors, exactly which technologies are going to be useful for us. So, our mission, we want to reduce the risk of cargo fires and loss by helping people explore, trial, and invest in the right technology so they can procure with confidence. So we want to remove that risk of trialing and testing new technology. Anchor partners, this is a program that has insurers, mostly ship operators, ship owners. It's a collaborative program. Everyone puts in, everyone gets out. Tenets of the program. This is not as much a research program as some of the things that you may have heard from DBI and Cargo Safe and Lashfire. What we're looking to do is build a practical technology acceleration program off the back of those research projects. So we want to leverage the insights and knowledge that people have invested in and say, okay, how does this work when we apply it to the real world even more so? It's about the latest and greatest tech. We're not looking at old stuff here. This is about what is bleeding edge, possibly from other industries as well. It's very practical. You'll have heard me say practical a lot, but I'm obsessed with it. We want technology on ships, operators, people looking at technology. How can you install it? Does it work? Does it cause false alarms? Real problems. It's about sharing. Again, like the big tenet of this is that everyone has the same problem. We can't be doing this in silos. It's expensive. People haven't got that much money. We need to come together. And ultimately, we want to influence the progression of regulation and class. Very quickly, why would you come together and do it cross-industry? It might seem obvious, but pooling resources is a really good idea because this is expensive and takes time and is highly risky because it might not work. So if one person trials one piece of technology, it might work, it might not. But if 10 people trial 10 pieces of technology, everyone shares in the risk, everyone shares in the success and the failure. The other thing it does is make it really appealing to researchers, people with new technologies, companies want to invest in a program like this. They even give you good deals. You leverage freebies and things like that. So how does it work? Everyone comes together, selects a challenge within the paradigm of cargo fires and loss. And lo and behold, the first two challenges were early fire detection on deck and in the cargo hold. And we've got a third challenge looking at container loss. We do a deep analysis of the problem. So we looked at Lashfire, Cargo Safe. What's the research saying? What have people already done in this area? We also produce a specification. So we go on board and we produce a detailed specification and context of the problem that a vendor in the market can actually respond to. It's not theoretical. Where do I put my sensors? How do I attach them to the wall? We do a really broad analysis of the global marketplace, both of people who are saying that they can solve the problem here and now, but also technologies that we think possibly could if taken from another industry. So we scour the globe, we make sure no stone is unturned. We bring them into pitching events that people can review and evaluate, and then we move into deep dives, and ultimately people select, us as a program, we select partners to come in to test and evaluate with. We do feasibilities, we run pilots, we run tests and lab tests and experiments, whatever needs to be done to understand whether a technology is applicable and useful. And the key thing here is that we tend to operate in a world where someone thinks of innovation and technology and they say, well, you're going to need £1 million, you're going to need, government needs to invest billions into technology. What we recommend is short, sharp pilots, proof of concept studies, feasibility studies. You do not need that much money to trial and evaluate a technology, but what you need is the impetus to find out, the impetus to structure the test, the proof of concept, to answer the questions that you might have. So this is what this is about. This is not spending millions on technology. It's a collection of short, sharp, very deliberate tests. So I guess what do people get in the program? We formalize it into a program. We produce collateral, enable people to make better decisions, all of that good stuff. And it comes together into a program. Lots of different projects collectively trying to solve the problem of, at the moment, early fire detection. So this is, I guess, getting to the meat of it. We've been doing this for about 18 months. We've had 8 different technologies into the program. All have come through technology due diligence. All have been vetted by our partners, by us. All have gone through feasibility studies, pilots, proof of concepts, like I say, whatever is needed. And we're looking across the spectrum because there's lots of different ways to actually detect fire on board a ship, far more than I could have even imagined when I first started this project, which makes it interesting, but really difficult. Because within each of these categories, you've got a host of different vendors who are providing different services. Some people are buying cheap Chinese parts, integrating it into a whole. Some people are building bespoke cameras themselves and have spent the last 50 years building that. So what do you choose? Do you choose the cheap parts integrated by a really experienced supplier? Do you go with the European partner who's invested 50 years of R&D into thermal imaging? It's really difficult, really different cost points, really different amounts of evidence. So when the guys earlier were talking about the cost-benefit analysis of, well, you should do this for this ship and that for that ship, I would say it's really difficult. It's really difficult to know without evaluating different suppliers and different technologies. So what have we found out? I'm going to give a very, very high-level kind of summary of things that we think we know at this point. Traditional gas sensing, forest fire sensors. Really, really traditional gas sensing is not that useful. It's been around for 100 years. But what you get now is IoT multi-sensors that have a variety of chips on them that can sense different gases. As we know, battery degradation, thermal runaway, gives off a host of different gases. And using AI, we can start to identify patterns in the air, molecules. This looks pretty promising. One of the interesting areas that's had a lot of progression in this space is forest fires. Because actually, forest fires were extremely prevalent, more prevalent a few years ago. And what you've seen is a host of really interesting IoT companies respond to that problem by building multi-sensors. We're in the process of testing these sensors on ships, and we're going through the motions of understanding how quickly gas leaves a container, much like some of the research has already done, and how efficable these sensors are. But what you're talking about here is a handful of sensors, possibly on deck, possibly in the cargo hold, maybe even at 500 quid a pop. So even on your smaller ships, you might start to think, well, we're not going to have thermal imaging cameras everywhere. But you know what? We might have a couple of multi-gas sensors that are actually going to give a real leg up onto the smoke extraction and human instinct that offers detection at the moment. But what's even more interesting is we're looking at cutting-edge technology using nanotech. So this is completely novel, and this is where nanotubes are placed onto a microchip. The nanotubes ingest molecules from the air and create a pattern that's interpretable using data analysis. What actually happens is different types of molecule impact the electrodes on the chip and the flow of electricity. But what this gives you is a signature akin to the human nose. So heavy fuel oil, for example, gives one signature, and you train that signature using AI, and then when the sensor detects heavy fuel oil again, the sensor knows that it's heavy fuel oil. And you can do that for a range of different scenarios. So we're testing this technology not just for fire detection, but for general risks and spillages. And the speed of detection we're looking at here is in a handful of seconds versus the amount of smoke that needs to be released. We're also looking into fiber optic. We even have a partner here today, so I'm going to be really careful about what I say and make sure it's all really positive. I think we all know about fiber optic because in Lashfire, surprisingly hasn't actually been deployed onto container ships very much. But what we do know is that fiber optic cable is extremely sensitive to heat. it's sensitive enough? That's not the question we need to be asking here. The question we have to ask is it worth installing this, retrofitting it into ships? Is it going to degrade, and is it going to obstruct containers and be damaged? Can the crew maintain it and repair it? These are the questions we need to ask, but also fundamentally, by the time heat has left a container and been picked up by the fibre optic cable, is it enough of an early response to validate the investment? Initial indications are that yes, right? Actually, as a pure heat sensing capability on a container ship, this is going to work. One of the interesting blockers we found is that the cable is so sensitive that it's actually responding to different environmental elements, and you can actually track the movement of the ship from day to night to north to south of the globe because the cable is responding to the ambient temperature. So we have to get through those hurdles in order to create a really specific signature that indicates fire. So I guess the short answer would be extremely promising, difficult to install, might be better on new ships, but fundamentally absolutely capable. So, really disruptive, completely novel, firing Wi-Fi radio waves around a ship. You don't have to install any wires, you barely have to put any sensors in. What you do is create a radio signature formed of transmitters and receivers around the ship. The disruption to the radio signal between the transmitters and receivers is caused by everything from changes to the substance in the containers, to the pressure, to the temperature. We've shown through quite a long journey of tests from shipboard POCs to lab tests that the technology here is a fraction of the cost of pretty much anything else that we're talking about. But using AI again, you can model the difference in radio wave change between the sensors, and you can extremely accurately detect heat and changes to the state of containers. This is early stage. We'd expect this to come to market possibly in the next 3 to 4 years. But again, this is really novel, and it's possibly going to change the game, but we still need to prove it out. Thermal imaging cameras, I probably don't need to talk too much. We all know how good they are. You can point them using your hand. You can stick them on the deck. We had a quote from a company for £5 million per ship. It shows the variance between possibly what a vendor wants to get out and what people are willing to pay. The key thing here is there any reasonable way of actually positioning a handful of thermal imaging cameras at specific points on the deck or in the hold that you could possibly look at your most dangerous cargo? Maybe. My gut says actually this is not the answer. This is useful for a handheld validation. Are you really going to be sticking thermal imaging cameras on the deck? It's questionable. I think there's too much technology. I think they're going to get damaged, but we're pursuing studies with companies to make sure that we've bottomed this out anyway. And I'm finished. I hope some of that was interesting. Please send any questions or grab me afterwards.
Perfect, great. So questions from the floor. Is this the microwave? Okay, but you can take it.
Yes, hello. Super interesting. Ville from DFDS. So, human factors. Do you need that we need more technology on board, or should we focus on the people? And how much you take the human factor in the considerations when you recommend these? Because you have to also think about the human response time on the next step.
It's a great question. It's like one of the fundamental questions. I think we throw technology into environments without thinking about stuff. I'd like to think we don't, but I think generally we do, and we wonder why it doesn't work. The short answer is I think we need both, but the reality, like the real value will be when we merge a really interesting piece of technology with a streamlined change or human factors integration. How are people going to respond to the alarm? What does it mean for them? How does it integrate with their day, their operation? And we're not quite there yet. We need to work out whether the technology itself even works. Then we're going to move into, fundamentally, how does this fit into someone's day? How does this alter someone's response to an emergency? So it's not really an answer, but I completely agree with you. And it's something that we think about a lot when we're doing this.
While we see if there's anyone else. Yes, just a second. I'm curious to know who's funding all this. Is it the industry? Is it Lloyd's? Or who's... Because you're doing a great job, by the way. It looks amazing.
This is an industry membership program. People pay a yearly fee, which goes into a pot which funds different R&D projects. That's how it works.
Thank you very much for the presentation. It was very illuminating. I was wondering whether the nanotube sensing solution gets desensitized over time.
Depends what it is, but typically sensors that are ingesting molecules like VOCs, gases, can degrade over time. A lot of sensors now are built. This is the benefit of doing this now rather than 5 years ago would be that batteries are much better. Components that don't wear out are much cheaper. So actually, it's a key thing that we look at, and we classify the resilience and lifespan of all of the tech that we do. But the short answer would be a lot of the stuff that we're looking at here, we'd hope you should be able to fire and forget for 5 years, to be honest, at least.
Question from Dawood from Rice Fire Research in Norway, by the way. He will also be part of the panel. He'll be working on detection a lot. I have another question, because we get a lot of questions based on myths, you may say, or misconceptions about, for example, batteries or how to detect them or how to extinguish them. What is the most common in the detection area question that you get that is based on the misconception?
The most common misconception?
Or any.
God, that's really difficult. I think batteries is an interesting one, and actually today is kind of backed up the idea that when we were looking at the eNose technology, actually one of the first things that someone wanted to look at was heavy fuel oil leaks in the engine room, not lithium-ion batteries. We're going to look at lithium-ion batteries, but actually that idea of day-to-day disturbances and risks that, has anyone talked about? Well, we did. I think someone did mention heavy fuel oil leaks, but often you don't. You talk about batteries, so I'd say that's a common misconception. Good question. I haven't necessarily got a perfect answer.
For example, we get questions about, you should use metal fire extinguishers for lithium-ion batteries because it's metal, or stuff like that, or asking. There are recommendations out there about you should use detection like puck kind of thing, or to detect the gases. From what we've seen, it's very difficult to detect the gas by a gas sensing unit. I don't know if you agree on that.
I think so. There is a lot of there is definitely a belief that it's too difficult to do by gas detection. But what I would say is I don't think that's proven out. I think even the fact that you have people detecting fires on deck by smelling it on the bridge suggests that there's really something to it. I think the issue is that because it's very difficult, you have different permutations of gases from different events, so you're often not just looking for one gas. Looking for one gas might be too simple. You need to look at either something like the eNose, which generates a real signature.
Training it by AI.
Or trained by AI, or a multi-sensor that's looking at different VOCs, different gases, and the value comes from actually, you can't just look at how much carbon's been released, or so how much CO2. You need to go one level below that and look at what's the combination of indicators that's going to indicate an emergency, and that's difficult, and people haven't necessarily done it very well yet, so people don't believe gas sensing is possible, but maybe it is. I would say it probably is. We just need to get to the bottom of those, training AI to detect a variety of different incoming molecules or whatever it might be.
Cool. Like I said, very interesting presentation. Thank you once again, Seb, for sharing with us. Thank you. And now I would like to welcome my colleague Staffan Braun from the Maritime Department to the stage, and he's going to moderate this session on Swedish sailor stories. Welcome, all of you.
Thank you very much. Good afternoon, everybody. So to counter the deep sleep phase of the conference now, we're going to do something a little bit different. Somebody commented on the name Sailor Stories. That's an informal name that sort of stuck in the process and planning of this conference. But it's not going to be about that time when you had to tie yourself to the wheel during a storm or anything, and that's difficult to do nowadays anyway. But it's going to be about experiences from the field, from the industry, experiences where our participants have worked to maintain or to improve safety in their fields. And it's going to take the form of an interview on stage. And we are going to keep the people interviewed on stage afterwards, and then we are going to do all of the questions when everybody's finished. So first, I would like to welcome Dan-Erik Andersson to the stage, who is the head of business area energy operation in Gothenburg Harbor. Please welcome. Yes. So, warm welcome, Dan-Erik.
Thank you very much.
On the screen now, we have a few different pictures from bunkering operations in Gothenburg. Could you just start by giving us some kind of sense of scale of the operations that you have in Gothenburg, the operations that you do with bunkering?
Interesting question, and I will not answer it exactly. Sorry. But depending from year to year is a little bit different, but we say that if you count the vessels, so something to say a little bit more than 3,000 bunkering operations every year, something like that. And different also heavy fuel oil, marine diesel and LNG, some also LBG. And hopefully also soon more methanol. We have also done a methanol bunkering operation last year.
And how big is this organization? You have people working, of course, on land and down to the operational level.
Yes, in so to say my apartment, my area in the port, we let's say a little bit more, 20, 25 persons. To running this around, and the business is going 24/7, so open every day, every time.
So there's a clue in the slide here that says green bunkering. So this is kind of a transition that you have been making over the last few years. Could you tell us a bit more about this transition?
The whole thing was starting a few years ago. There was a leakage in a bunkering operation, and it came heavy fuel oil and diesel oil into the sea. So there was a lot of discussions. We need to stop this, and it's not able to do this anymore. But we thought in the port and along to the local authorities and fire brigade and so on, that this is important for the port because we are a pretty big bunker hub in the port in this area. So we thought that we need to do this in a safe way. So then we started up this, so to say, concept and had a good cooperation with authorities, transport agency, maritime administration and so on, Coast Guard. And so we could do this in a safe way. So the most important thing is to do it in a safe way and also efficient way. So the ship is, when they come into the port or if they stay at anchorage, so they can do the bunkering operation and do it in a safe way and then leave again.
I'm wondering a bit about the green part here. So you mentioned reducing spillage, for example, from ships. That's an apparent environmental benefit. But are there other aspects of the green bunkering? The word green.
Yeah, yeah. The green is maybe it's very old, maybe, but no. And there's also some kind of link into the future also for us because we are what I say. This is a big bunker hub in the area, and we also want to be that in the future. And we also want to show that this is possible to do the bunkering operations with the new fuels coming. So I think it was about 2016 we did the first LNG bunkering operations in the port, and it was possible. And nowadays we do it regularly every week a few LNG bunkering operations. And then also in this concept, we saw that we need to be sure that the crew on board the bunker barges, that they need to be educated. So we're starting up also web education. And up to this date now, I checked last week, I think about 2,400 sailors have been doing this web education. And then also we have some kind of demands for the vessel that do the bunkering operations, what kind of equipment they need on board so they can deal with a spill or something like that. And then also there is a kind of vetting system. So every year these bunkering vessels need to have some kind of visit on board, and that need to prove that everything is okay and they have the equipment and the crew is educated in the right way. And that is also one of the reasons that we see that we want to go further. We want to go into new fuels, and so next in line for us now is to bring up these operating instructions for ammonia bunkering also. So that's the next step for us, to establish that in the port, to be able to do that.
This is something that I was curious about. So there's a lot of variety nowadays in terms of fuels, new fuels coming to the market and becoming established in the industry. There are certain procedures for each and every one, different technologies involved. How do you tackle this from a safety point of view? And I'm thinking also of the bunker barge crews, for example, to have this large variety in knowledge that you need to have, and knowledge about different types of equipment and technologies and so on. How do you tackle that?
In this concept, with the green bunkering concept, we have different kind of chapters. So there's an LNG chapter, methanol chapter, and the original heavy fuel oil and the gas oil also. And now this ammonia, it will be a new chapter also. And every second year, you need to do this education again. So then it's possible to refresh. And also when there is new bunker barge coming up into the port, they need to start up with this concept also, to do this education into the web and everything. And then also checklists. So we have the checklist for everyone, and it's when it's LNG, that's a separate checklist for LNG, and marine diesel, separate checklist. So I think that's a pretty good way to do it, and make it so easy as possible, but also so safe as possible.
Right. Have you assessed the efficiency of doing what you're describing here, the web-based education and using checklists and so on? Are you getting the results that you're after in terms of safety performance?
Yes, touch wood. Almost never accidents. So, but we think it's good. And about, let's say, a year ago, we had a bunker barge in the port that wasn't so good, and we saw that into this vetting inspection, that there was a lot of bad things. So, and that was a good way to find out about this. And then we took a discussion with the operator, and they took measures to fix the problems. So I think it's a good system and it's working. So it's not just on the paper.
Yes, thank you. We are going to finish now, but I was also curious because there is a lot of talk now in society about the role of shipping in civil defense and the role of the maritime industry in particular in maintaining our civil defense. So what kind of role for the bunkering operations do you see in that picture?
We talk a lot about different kind of fuels and so on, and I think that's important for different kind of vessels, different kind of trades, that it's possible with different kind of fuels, I think. So I think that's the most important piece, that if you come to the port and need heavy fuel oil, it should be possible to get it. And we see perhaps also for these naval vessels, they don't want this new with stuff into. They want brand old kind of fuel. So it's very various demands.
I see. Thank you very much, and I will invite you to take a seat in our lounge area here.
Can't be better.
And then I would like to welcome Christian Andersson to the stage. Christian, who is the man of many titles, maybe. First chief engineer, I'm calling you this slide, of Öresundslinjen.
Yes.
And I know that I chose perhaps a more serious and descriptive title for this presentation first, but then I listened to this song the other day, Electric Avenue, and I think it's a good fit for you. So now it's Öresund Electric Avenue.
Yeah.
So Christian, will you maybe start by giving us a picture of the context that you're operating in, Öresundslinjen?
Yeah, we have it's a ferry route with 4 ferries trading between Sweden and Denmark, and we have about 6.1 million passengers last year, and transported 1 million cars and 430,000 trucks, and we had about 42,000 departures, and we have 2 electrified ships running on the route since 2018.
Right. So in the bottom right picture here, we see you, yourself, and another gentleman in a room full of electrical installations. Could you, what are we looking at here? Could you introduce us to this?
Then we look at one of the battery rooms on board one of the ships, and it's started in 2014 when we did an investigation and checked if it was possible to run the ships, the 20 minutes crossing in batteries. And we looked at the market, what was possible to do, and we checked the energy profile of the ship, and it was possible to, we thought that anyway. And then we applied for a grant from INEA in 2015, and it was approved also in 2015 to assist us with a heavy investment. And then we started a pre-hazard analysis, and we started to investigate with the grid suppliers if they could supply us the high energy demand that the crossing was needed to have. And when that was okay, when we checked with the grid supplier, we thought that we could continue and start a specification, which we did together with OSK Design in Copenhagen. And then we sent out some tenders to a couple of suppliers, and in 2016 it ended with a contract with ABB Marine to electrify two ships with 4.2 megawatt hours, and also we they had to supply. They had a turnkey solution with also with a short charging system. So that's what we are looking at, and also the fully automated robot system.
So you mentioned that you started looking into the possibility and you made it a reality, but what was the motivator, the main driver behind this change?
Yeah, it was okay. At that time it was the marine gas oil was very volatile, the pricing, and the electrical energy was quite okay. And also we are trading within the city centers in both ports, so the local governance wanted that we should do our best to reduce our greenhouse gas emissions, and so I think that was a combination. And also we were looking into fuel EU maritime and EU ETS regulations, so all in all it would be hopefully a good investment to do this.
Right. So I realize that this is a big change from a technological perspective, but then I would also imagine that when you do a change like this, it brings with it a lot of other changes. So from a safety point of view, could you tell us something about what changes you needed to make in terms of, for example, the crew's knowledge or operating practices? Or
yeah,
like
it was really important that the crew were skilled and got the right educations in high voltage, for example, here at Chalmers University. All the engineers had that, and also we had to learn about lithium-ion installations with NMC cells, and we have learned our lessons very hard actually during the years, and but it's very important that you can read and understand all the information that you get from the BMS system, and so you can handle the state of health tests and the resistance test and analyze all the information to understand the degradation of the batteries, and we're talking about fire and safety today, so that is really important for the crew to understand all of that information to avoid a thermal incident. So I think we have learned a lot during these years, and I think that's the big change for the crew today. We talk a lot of these things and topics all the time.
this thing that you're mentioning with interpreting the information that you get from a large battery installation in case of fire. We know that this is also a problem with land-based rescue services and so on. Have you had any interaction with the rescue services around approaches to the installations in the case of fire?
Yeah, we did quite a deep fire philosophy during the process, and we have analyzed how to handle a thermal runaway, and we have a lot of cooperation with the local fire brigades on the Swedish side and on the Danish side, and we try to educate the crew all the time with new findings and whatever is coming up, new information. So that's a really important part for us.
What has the reaction been to this change from the crews and from their perspective? What has it meant for them?
I think it's meant a lot of good things, mostly. I mean, we had no bigger drawbacks. It's been more positive, and they've been really engaged in this new green way running the ships, and I think that's part of the success that we managed to have them. They're interested in this, and that it's really needed when you do this change, that they are a big part of running a ship with new equipment like this.
Do you see this as the future? You mentioned yourself the market changes and fuel prices change and so on. Do you see Öresundslinjen continuing on these routes?
Yeah, definitely. We're going to invest in the electrification of the next ship next year. We already signed a contract, and we believe in this. This is a perfect way of reducing the greenhouse gases and everything for a typical route of this that's 20 minutes crossing, and also extended routes can use this technology.
Right.
Yeah.
Right. Thank you very much, Christian, and please have a seat.
Thank you.
Then for our last participant, that is Jenny Folkunger from Trelleborg Harbor. Jenny, who is the head of environment and sustainability in the port of Trelleborg. So welcome, Jenny. So Jenny, in the pictures here on screen, we see rescue services. We see rescue services interacting with crew members, and what's going on here in these pictures?
Yeah, those photos are actually from a fire drill that we did last year, where we involved as many stakeholders as possible, and that was a very rewarding experience for everybody. I never realized how big of a lack there was in that area. I sort of assumed that there were drills and that people spoke much more than they actually do. There are some barriers there that I was unaware of.
Right. Could you tell us a bit about how this initiative came about? What spurred it from the start?
I would say that it came from what Guy was talking about earlier today, because I don't have a background in fire safety at all. I'm a lawyer and biologist by trade. I just find this interesting, and I think I come from a long line of hobby pyromaniacs. And there was a fire on a car ferry outside of Holland, I think, right about the time when I started in the ports. And I thought to myself that that's a car ferry. We actually have RoPax ferries. We have passengers on board. Are we really on top of this? Do we know what we're supposed to do if something happens? And I didn't feel that we were talking in the way that we should. So I wanted to gather everybody in the room, and I did a workshop on lithium-ion battery fires in a maritime sort of perspective, just so that we could get everybody talking and we would see what was my fears and what was myths, and so that we would operate from facts.
Right. So you mentioned this incident that sort of made an impression on you and set you on this course. So have you had any experiences of your own in the port of Trelleborg where sort of the whole emergency organization has been put to the test?
Luckily not. There has been some fire incidents and spills. There was a fire in a washing machine, for example, but I haven't been involved in that. But right before I started also in the port, there was unfortunately a fatal incident where a dredging ship turned over and a person got trapped inside and sadly died. So there has been some experience, and I always think that we can learn more from those type of incidents than we actually do. I think we could penetrate much deeper. What could we do better? What happened? And communicate more about the expectations on different players in such an incident.
So how did you go about it practically to bring all of these different parties together? Because there are quite a few parties that need to come together if there's a larger emergency.
Absolutely. For the drill, that sort of came from the workshop where we found each other. You know how you say your vibe attracts your tribe? I found Martin from Stena Line, who works with these issues, and one of his colleagues who's a marine superintendent, and another colleague from Fire Brigade in Trelleborg, and we just started talking about the drill. And then it turns out that people are quite interested in this, and people are hungry for this type of opportunity. So it wasn't hard to get players from Coast Guard, insurance, local authorities, other ports, ferry companies or shipping lines. So getting people together was actually the easy part, but there was a lot of planning that went into it that I didn't realize in advance how much planning it would require.
I'm curious about learning. So this is a big thing to organize, and a lot of parties involved and a lot of planning involved. But how do you ensure learning, that the people involved actually learn from this experience?
Yeah. I think it tends to happen quite organically, especially for the people who is involved in the actual work. The planning phase was probably where I learned the most, and then you can spread that knowledge. And in all the planning sessions that we had, we would get the relevant people in, and we would learn from each other and sort of realize limitations in our organizations. What expectations do we have of each other? Does that match what I think that they think we can do, and vice versa? And what equipment we have to use, and just talking about all of those things were extremely useful. Another thing that we discovered was that, okay, if there's a car that's on fire, and then at some point, as soon as possible, you want to get it off the ferry, logical. But every different actor that was involved assumed that somebody else would do that. So the shipping company, they sort of assumed that the port will take care of that. And the port was like, oh, no, the fire brigade will take care of that. And then you have a labor union who's like, oh, wait, work safety, like that's not going to happen. So that was a part of a process that I didn't foresee.
Interesting. So that about learning, then what have you learned? Could you mention some concrete takeaways from the drill that you did, this large scale exercise?
I think most of what we learned probably surrounded communication. For example, we discovered that the radio that the fire brigade use, it sort of dies after 2 floors because it's a digital signal, and they had to think about where they put extenders to have that function, and how do you communicate with the crew on the bridge and with the port and all of that. I think, of course, there were practical issues as well as nozzles and how do you attach them and trying all of that. But the most valuable part is probably the communication, I think. That's probably also the most difficult part because it depends to a certain extent on the interest of the people that are involved, and it's very much something that is fresh. And if you don't maintain it, it's going to die out.
So we have an example of that communication here in one of the pictures from the bridge, I think,
Yes.
with the intense discussions about approaches to the fire scenario. This picture made me curious because, of course, rescue services, they have a lot of knowledge about some fires and approaches to different types of fires and in different contexts. Is there any learning happening in that respect between the rescue services and the seafarers on board?
That wasn't the case previously, but now it is, because we quickly learned that the different teams working in shifts with the fire brigade, many of them had never been on board a ferry. And then, as it turns out, a fire on board a ferry, that is the absolute worst case scenario that can happen for them. So it was very important to get them on board. So now all the firefighters in our municipality have been on board the ferry. They've seen the bridge and they know more about how to orient themselves. And yeah, it's different to communicate with somebody and you have responsibilities and a chain of command. And I think that not everybody are comfortable with that or know how to approach it.
Thank you. So what's the next step for your work? Are you doing this again?
Absolutely.
Do you have the energy?
Absolutely, absolutely. We're trying to do it again in 2025, and I think that we will be focusing on evacuation of passengers. There are many aspects of that involved ISPS from our perspective, for example. And for the fire brigade, how do you search a passenger ferry in a systematic and efficient fashion? So there are many interesting aspects that go into the evacuation of passengers.
Right. Thank you very much, Jenny.
Thank you.
An applause for Jenny. So now there is time for questions from the audience. Do we have any questions? We have one over here.
Yes, Ville DFDS. Yes, good. Thank you so much. I have a question for Christian. So you said two questions. One is that do you see any significant difference with the operating cost now operating full electric compared to having a diesel engine motors on board? And the second question is that you said that you had some lesson learned. So you're now doing a third vessel. So what have you learned from those two vessels that you're going to do different on the third one?
Yeah, to start with your first question, it's a much better financial review when you're running in electrical mode. So that's one very positive thing. So we save money every trip we do. And when it comes to learnings, there's been a lot of, we've gone through most of it. We abused the batteries by overcharging due to wrong settings in the software. There were design failures that came up when cycling the running current hardly like we do. We had a lot of issues with the charging system in the beginning, and with many factors that we didn't expect to have. The ship is docking very quickly and unloading and reloading, so there's a lot of things going on. So we had to update the equipment for setting the ferry's position, etc. when the charging robot. So there's many things. We had obstacles and things with the cooling water. There's so many things we've gone through. So we it's been a struggle, but now it's going good, and but it took some time, and I'm happy to share it with other operators or whatever. Just send me an email.
Yeah. Thank you, Christian. More questions. We have one here that I can see.
Thank you, Rupert Scott. Just another question for you, Christian, if you don't mind. What's the regime for recharging the batteries? Are you charging them up after every sailing, or just once a day, or
no,
how long do they stay charged?
We charge after every crossing. We have a DOD of 27%, so we run down to 39%, and then we charge to 66%, and that's our profile. So we have cycled over 70,000 cycles now for the first installation, and it's still degradation of about 2% yearly. So it's much less degradation than that we expected.
Thank you. Another question over in the back.
Thank you. Just a simple question for Christian. And can you tell me which type of additional training, in addition to those provided by SSCW, may you suggest for the crew operating a full electric vessel, if any, of course?
Yeah, first of all, they need to be they need knowledge of the BMS system, how to operate that, and from the supplier, depending on the supplier, because most of the suppliers have their own BMS system, so that's very important. And then you need education in electrical safety, personal safety, and electrical accidents, and also how to operate. In our case, we're using lithium-ion batteries with NMC cells, so we got special in education in that. So I think it's very much up to the operator. What system do you choose? And when you have decided that, you have to educate the crew as much as possible into that. There's, of course, general information, but also about the specific system for the installation. So it requires really skilled people on board the ship to handle all the different issues that we've gone through. So, but if you're prepared, you can handle them in a good way, hopefully.
I have a question back here from myself. I'm wondering from the ports, I've heard a lot of discussions or thoughts about creating electric hubs, so like a battery hub in the ports that could serve both ferries, of course, but also the rest of the city, and also work as a backup. It could have many purposes. Is this something you've been thinking about or planning, or how do you look upon that in relation to other fuels, so to say, with regards to safety?
Well, from our perspective, that you might have understood from my question earlier, is that our port in Trelleborg is right next to the city. The inhabitants are not many meters away from our fence. So for us, storing larger amounts of any fuel is extremely problematic, and we would not get a permit for that. It's just not happening. So for us, the only option is basically ship-to-ship bunkering or lesser scale truck-to-ship bunkering. So from our perspective, batteries would be absolutely interesting, and Last week I was at the MEPC committee at the IMO, and I think that regardless of opinions on it, there will be a discussion on nuclear barges, for example.
Yeah, and from our port also, I think we've been looking into a lot of different kind of solutions, but we see that it's a struggle to bring enough energy down to the port. So there is a lot of discussions and intensives, but it's hard to get enough energy. But sure, for the future, I think that there will be some kind of solutions with the batteries and so on. I think so.
Yeah, Oscar from Rice, and I have a question for Christian. In what way have the rescue service been involved in your electrification? And since you also move between two countries, how have the rescue services been collaborated? And also, have you been conducting any action plans or strategies that both of the rescue services are agreeing with?
Yeah, we have a lot of training on board. So the local fire brigades on both countries, they are well aware of our installations, of the fire philosophy in the water cooling system, the aerosol system, the drencher system, the outside drencher system of the containers where we're situated. So we train together with them on board the ships actually, and also at the fire stations. And the collaboration between the fire brigades in both countries has been fantastic, actually. They've been working a lot. We've been working with them, and I couldn't expect that they should be so energized and interested in getting to know about our installation, and also actually in Helsingborg, our lithium-ion installation is considered as a bigger hazard, like the bigger industries in our area. So they put specific attention to any incidents that we report, and we also try to be really transparent and inform them if something is going on or whatever. Expectations that we didn't, or things that we didn't expect. I guess that's the answer for your question.
So we have time for at least one more question, I think, starting here.
Yes. Okay. Daniel from Chalmers again. I have a question to both ports that are present here. And since you are conducting drills, that was a very interesting concept. Do you have any conclusions, like written reports or anything like that you could potentially share? Because for us as a training institution, that would be very interesting. And also, I would like to just put forward that we have a lot of students with basic safety training in various stages of education. So if you are interested in participation, like statists or like any kind of, to play passengers or crew members, just reach out, and I think that can be arranged. Thank you.
Absolutely, they're more than welcome.
Yes, very interesting. So, but then we have done.
I think we have 3 questions. Åsa, Marco, and then.
We have done exercises that you can take.
Åsa Byrman from Lighthouse, and I would like to ask Dan-Erik, the green bunkering, are there other ports that actually have taken after and doing this, or is it just Gothenburg still?
We have had a lot of discussions with other ports, both in Sweden and other countries, and I don't think the full concept, I'm not sure if anyone have brought up in their own port, but I think they have taken some good pieces from this concept, I think.
Because as I remember it, if you did not have a certificate for green bunkering, you were not allowed to bunker.
Exactly. So when there is a new bunker barge is built or in some other way coming to the port, they will start with this to do this green green bunkering certificate. So, and when they have done these different parts and also the vetting inspection, they will get approval from our side and a certificate. So that's right.
Hi, I'm Marco Martinelli from Grimaldi Group, Napoli, Italy. So I have a question for the two managers of both ports of Teleborg and also Gothenburg. If electrical operated vessels or hybrid vessels have some advantages regarding tax reduced fees in your, if calls your ports. Thank you.
For the moment, there is no such things in our port, but of course we have had different kind of incentives to support the shipping industry to do this kind of changes in the machinery and so on. So there is one ship owner in the room that have been able to take care of this, to take advantage of this intensive a few years ago. So as the time went by, there was it's not impossible to do that kind of things.
And with that, we need to thank our participants, Jenny, Dan Erik, Christian, and give them a big hand.
Thank you.
Thank you.
See,
and before we move on to the next presentation, we have an invitation for you, actually. So next year, it's once again time for Donsö Shipping Meet at the lovely island of Donsö in Gothenburg Archipelago. It's a trade fair, meeting place for the whole maritime industry. And this is the third time that DSM will host the Safety Meet. And the Safety Meet is a conference arranged by us at RISE and the Swedish Ship Owners Association. We've heard this many times today from Geir from Skuld, for example, that people can really be seen as a resource for safety, and there are many new technologies coming to the maritime field, and there's a need there to find a good fit between these technologies and the people that are working on board, and to find good ways of organizing the work that they do. And this is going to be the theme for next year's Safety Meet, people and safety, both how people contribute to safety, how we can support that contribution through designing equipment, technologies and environments around them, and also how we can protect the safety of the people that work on board and provide attractive workplaces for them. So please join us at the Safety Meet during Donsö Shipping Meet 2025. It's going to be good.
Thank you, Staffan. Exciting, and there's obviously a lot of new challenges for crew to take on with the new fuels and all these new items and challenges for them. Jenny, could you give a clarification? Is there a public report that is available, or is there a documentation that you could send out regarding the exercise?
It's not super formal, but it could absolutely be published. Yeah.
Okay, so there's a report that is shareable, so talk to Jenny if you're interested. Now there's Fika again for 30 minutes, so we'll meet back here at 2:40, so almost 30 minutes. Enjoy! Okay. Please make your way back to the conference room. And for those of you who are here, please pull up your phones and we'll launch the next Menti question. I forgot to do that before the break, so I'll do it right now. And the question is, what technology do you believe is the most promising for early detection of battery electric vehicles? So think about that for a moment. And we heard about, from the safety tech, Seb Corby there, a few hints about what he thinks. What do you believe? This is a hot topic in the industry right now, early detection, and we heard about it from a few presenters, and there are projects ongoing as well. So I'm sure that will be part of the discussion in the panel later on. But now, the first presenter after the coffee break is Grete Hørsbøl from the MAIB, the Danish Maritime Accident Investigation Board, DMAIB. So very welcome to the stage.
Thank you.
A round of applause, come on. Woo. I will close this down. Is it working, by the way, the Menti? No? Okay, I will just kick it on here.
So meanwhile, I can just say that my name is Grete Hørsbøl and I'm a marine accident investigator from the Danish Maritime Accident Investigation Board, which is a teeny tiny unit in the Danish government tasked with investigating marine accident, very serious marine accidents, and the purpose of our investigation is to gain safety learning. Sorry? Okay. So today I'm going to speak about an accident we investigated last year. It is a fire investigation, or an investigation of a fire accident on the Danish vessel Stena Scandica. It occurred on 29th of August in 2022. And for us, for investigators, this is a perfect accident. Yes, you get a peculiar interest when you deal too much with accidents. But it is perfect because no persons were hurt during this accident, but it was severe enough for all of the ship's emergency systems to be activated. And stress test. It was stress tested live in such a way that a lot of systemic vulnerabilities was exposed, and that is really great for investigators. But because that leads us to having the opportunity to trace how catastrophes unfold. Today, I'm going to talk about just one of the systemic vulnerabilities that we found. Which connected to the functionality of the firefighting system on board. There was a lot others, but you can read the report and get wiser on that. So just a short introduction. Stena Scandica, Danish flag RoPax ship, which can carry 922 passengers. It is in a fixed route between Nynäshamn in Sweden and Ventspils in Latvia. On the day of the accident, the ship departed Nynäshamn about 9 o'clock, and at 12:15 it had a fire alarm. It was quickly established that the fire was on vehicle deck 4, and the passengers was immediately evacuated. First to the muster station on deck 5, but as deck 5 is just above deck 4, smoke started to fill this muster area and they have to be evacuated further up in the ship. About half an hour after the first the fire alarm was received, the fire was actually already under control. As you can see, this is actually how the stowage was on the deck on this particular day. So there are not many trucks stowed in this area. So the firefighters could fairly easily move around on the deck with the hoses, and so hence it was quite quickly under control. Half an hour later, a total blackout occurred on the ship. leaving all ship systems, having a total loss of all ship systems, including the loss of navigational equipment, loss of steering, the loss of propulsion, loss of power for all the anchor winches, loss of water supply for the fire hydrants. So nothing was working on the ship at this point. This situation went on, but at 20 o'clock, the crew managed to restore propulsion on the ship by applying a vast amount of creativity. The ship could return safely to port. There was, of course, damage to the deck, the deck on where the fire occurred, but otherwise the ship could return on its own. So this accident had some catastrophic potential. If the fire had not been extinguished prior to the blackout, the fire could have spread uncontrollably because there were no firefighting system available. And also second catastrophic potential, which was that the ship drifted uncontrollably for several hours and was not that far away from grounding severely just north of Gotland. But none of this happened, so that was great. Now, the source of ignition was fairly quickly identified. It was this truck, and the source of ignition was to be found in this area. We could not point out the exact point of ignition, but it most likely was some sort of component failure on either the truck or the reefer trailer that it carried. So, some sort of component failure. The thing is, so in normal old-fashioned investigations, you would say that this was the root cause, and if we can just fix that, then ships will never have a fire again. That's not how we do it anymore. We are interested in finding out more about how the ship's systems work. And when we look at this and can see that there is a defect electric component, a failure on that can lead to a catastrophic, massive catastrophic potential, then there is not proportionality between those two. The defect cannot explain the catastrophic potential. So we have to find out what is in between. What makes this accident escalate? We decided to take a look on the vehicle deck. What sort of compartment is that? And what we did when we characterized this is that we could conclude that this is an area of expected fires. There are many uncontrolled sources of ignition just driving on board. This can be cars, reefer trailers, camper wagons, carrying all sorts of things, and everything can ignite. There's a high concentration of flammable material, so if a fire occurs, it can also quickly spread. And because it can be very tightly stowed on the vehicle decks, it can be quite difficult to move around between the vehicles. And this actually makes vehicle decks a quite hostile environment. And this is acknowledged, and therefore there is preparedness to handle fires on board vehicle decks. It is acknowledged that early detection of fire is crucial so that we can avoid the spreading. Furthermore, that early activation of the drenches can also limit the spreading once the fire occurs, and that there is a quick response from fire teams with hoses to pour water and cool directly on the object on fire. And this is something that there's a lot of attention to when it comes to drills, for example. So this is trained. One of the things that is important to be aware of is that all firefighting on the ship, which I've just mentioned before, is dependent on electric power, especially for the water supply. So the fire preparedness is actually dependent on the power supply on the ship. So we also thought, well, we also need to look at the characterization of that. So this is the normal power supply on Stena Scandica. We have the main switchboard in the engine room, or the engine control room, which delivers power to the emergency switchboard in normal service. And the emergency switchboard delivers some control voltage to the main switchboard, which is essential for the main switchboards to work, and furthermore also supplies a lot of safety critical consumers in the engine room. So this is one integrated system during normal service. If an emergency occurs, which means that for some reason the power supply in the main engine switchboard suffers a failure, well, then the emergency power supply system are self-sufficient, because there is an emergency generator that will automatically start and supply the emergency switchboard, which will then supply all the essential consumers and also allow for a restoration of power in the main engine room. So you cannot really say there's a redundancy, but there is a backup system in the emergency at the emergency switchboard and the emergency generator. The emergency generator room is located on the 8th deck on the forepart of the ship, in the total opposite direction of the engine room, which is in the bottom of the ship, aft. This is deliberately because we want the emergency generator being protected from all sorts of risks, especially fire. So it's placed far away from everything that could harm this, the emergency generator. But this also means that there are some cabling between those two areas of the ship. And this cabling is, well, it's collected in cable trays like an umbilical string in the longitudinal direction of the ship. And you can see them here. Where are they located? Where are they installed? Well, they are installed at the deckhead on the vehicle decks, for example, on deck 4. So what happens when cables are directly exposed to a fire plume? Well, they are marine cables. They are able to withstand fires to some extent, but not a truck that is ablaze for half an hour. So as you can see here, the cable trays are heavily damaged. This means that this umbilical cord through the ship was now cut in two. What consequences does that have? Well, first of all, short circuits in this area where the damaged cable was, they started to occur, especially due to the cables were lying next to each other, but also being exposed to water. This caused short circuits to occur up on the emergency switchboard, which was, you remember, the last thing that should be fall was the emergency switchboard. This was now the first thing that fell. And the protection mechanisms that are to protect the emergency generator from receiving some bad voltage or some failure power, it protected it from getting on the power grid. So the emergency generator was working, but it was not able to connect on the grid, so it didn't supply emergency power. The main switchboard were not able to function without receiving the control voltage from the emergency switchboard, so this also blacked out. And the cables that was connected from from the emergency switchboard to the essential consumers were cut. All of this together caused a situation where it was very, very difficult for the crew to actually restore anything because it was destructive. But to the firefighting system, the consequences was that the fire pump lost power supply, meaning no drenches for 3 hours and 45 minutes, and that the emergency fire pump lost power supply, which means there were no water in the hoses for 1.5 hours. So let's just take the systemic look on this once more. Fire is expected on vehicle decks. There's a high concentration of flammable material in a tightly stowed compartment, which means that it can quickly spread. Therefore, the fire preparedness is essential for the control and the extinguishing of the fire. The fire extinguishing system are dependent on power supply. The emergency power supply rely on intact cabling. The ascension cabling are installed on the deckhead on the vehicle decks, which are installed in an area where fire is expected. So you see now there's a systemic short circuit here. This is the recipe for disaster. If this, we are not keen on doing if-then analysis, but here it is really, really tempting to make an if this vehicle deck had been stowed just a bit more tightly on this day, then the crew would not have been able to extinguish the fire as quickly as they did, and then they would have been in a situation where they had a fire and no firefighting system available. That would have been a disaster. So what is the problem? Back in the 80s, an American sociologist, Charles Perrow, wrote this banger of a book called Normal Accident, where he explored the concept of systemic accidents. And it is accidents where it is the complex interaction between subsystems that are engaged in some unexpected sequences and unexpected interactions. This is exactly what occurred on Stena Scandica. And it is also a problem that never occurred to the designers. We can see how emergency systems are designed on ships, and the combination of the cabling and the firefighting system, I don't think that was identified on Stena Scandica. But it is also what is called a normal accident. And it is called normal because there's no failure actually in this system. It is what we see here, the escalating events on Stena Scandica, was integral characteristic of a system. It was not any deviance taking place. But it is also normal in another sense, unfortunately, because the system that we see here on Stena Scandica is not unique. There are several other ships sailing with the exact same design. And this means that the potential for catastrophic outcomes are present across the RoPax industry. So that was all for me.
Yes. Do we have any questions down there? Yeah, you have to take the. He'll give you a mic.
Okay, I can ask a question. So, what's the follow-up? I assume that you're going to follow up with this IMO because it's clearly a system mistake within the industry.
That is a good question. The thing is, we are an investigation board, and what we do is that we very carefully explore the problems that are that we see when we are investigating accidents. Though we are not a part of the solution-making business because it's not our profession, but we deliver the data on the problems, and then those who are better have better competency in doing the solutions, we just supply the knowledge for them. So this is for the lawmakers or the business or the industry to take this into account if they find it relevant.
There you go. Was this a Vicentini ship, the Stena Scandica, or
what ship?
A Vicentini series? Yeah, I think so.
Yeah.
And similar to I think there were similar conclusions already from the Norman Atlantic that this occurred, this blackout. So I'm just wondering, or why hasn't it been retroactively fixed, this blackout problem? Why can it occur again? Do you have any thoughts on that?
No, I don't have an answer to that. But what I can say is that we looked into how this ship was configured and measured it up against the regulation, the requirements in the regulation, and we could not find that this ship deviated from that in any way. So.
I don't know about safe return to port. I mean, current safe return to port regulations must handle this, right? I'm looking at CFIS.
Yes, definitely. I would like to comment on that. We had Lloyd's Register, and I think I was asked to read that report, but because DMA did not consider using LR as a recognized organization, we kept it internal. Yes, this problem has been resolved for safe return to port vessels. What strikes me in this, well, it didn't strike me in the report, but in the commentary I heard today, is that the essential part is lessons learned and recommendations. It's not for the investigation branch to put the investigations, to put the recommendations. But definitely, this is the third vessel that, well, I personally know of, that suffered from the same design characteristic, because it was 100% compliant at the time of build.
Yeah.
Wouldn't be compliant if it was built now.
Right.
So normally, I would like to ask, you introduced yourself as a part of the Danish government. Was there anything from the flag to the owners to actually rectify this problem, or the vessel has been restored exactly as it was built and continues to happily trade?
I think the Danish flag is here. Wait for a microphone, and this will be the last comment. We have to move on after this, but interesting.
Vem är det?
Here, in the front.
So thank you. I work for Stena Line. I started 2 weeks prior to this accident in Stena Line. Good start at the new work. What we've done for the Vicentinis is we have protected the cables with paint. The one that will expand when exposed to heat.
Intermittent coating.
Will give you some more time. Will not be equivalent to safe return to port, but it gives you more time. So that's a recommendation from FLAG.
Good to hear that you're taking it seriously. Thank you very much for your presentation.
But,
last words.
Yeah, if I just can make a short comment, this is not just for passenger vessels that we see this. We have also seen this type of issues on, for example, in engine rooms, where engine room fires, and it's the same problem with the electrical installations in the roof that can just make the entire ship black out. So, yeah.
Huge problem. Thank you very much. Very interesting presentation. And she will be available on the break, right? So, from Tank, welcome Claes Möller. And I will get your presentation ready momentarily. Please introduce yourself.
Yes, my name is Claes Möller. I'm working in Tank. And I have a seagoing experience of, yes, in Tärntank 10 years first, and then over 20 years at the office. So I've been more than 30 years in Tärntank. And in Tärntank, we have been working quite much with this employer-based dialogue from a safety perspective. Var är den då? So our motto is that when a vessel is designed and built, everyone is engaged. Our aim is to build vessel in which we ourselves would like to be working any position. So that is the motto of Tärntank. And we are a family company founded in 1958, and we are based on the island of Dunse and Skagen, Denmark. All our vessels are Danish flag. So Dunse and Skagen is no metropoles, but we like it very much. And today we have 9 oil and chemical tankers, 10,000 tons to 15,000 tons. And we are we are 270 employees on board and 20 ashore. So therefore we are a quite small organization ashore, which means that we need to engage our crew on board, because we have everything in-house. We have new buildings, we have everything in-house, so we are engaging our crew for all different purposes. And right now we have 5 new buildings under construction, and these are the new buildings, not the top one, the below one. Yes, and we have been talking quite much about fuel today, and so we have in our fleet today, we have diesel for the older vessels, we have LNG, LBG for 4 of the vessels, and then we have LNG, LBG, and electricity on 2 vessels. And the 5 new buildings will be with e-methanol, wind, and electricity. So we have batteries, we have shore power, we have LNG and LBG and diesel vessels. So we have it more or less everything. Maybe it will be ammonia in the future. We have to see. And our trading is Scandinavia. And we are transporting fuel for the transport industry, which means gasoline, diesel, and jet fuel. And that is an advantage for us when we are talking about fuels also, because we are, all our crew, the whole company is very aware about the risks and so on with regards to different fuels, because we are handling it every day in the normal. And now, as it is now, it is coming more and more into these fossil-free products as well, such as animal fat and so on. We are also transporting nowadays. And here we come. Our crew is the core of the business. And that is really what it is, because that is why we are able to do business, is due to the fact that we have our crew. And our crew comes from Sweden, Latvia, Poland, and Philippines. We have a mix of crew in all positions on board. And we can see now we have Poland there, 1999, it's 25 years now. So 2 weeks ago we was giving 5 gold watches, which means that they have been in the company for more than 25 years. So and that is why, not why, but our retention rate is extremely high. It's very close to 100%. So therefore, it is also an advantage for us when we are building vessels and improving and so on. And when is the crew involved? They are always involved, of course. They are engaged, but as soon as we are deciding to build a new vessel, we are engaging the crew. And that is normally by appointing one new building manager, which is normally a chief engineer or a second engineer on board, which is coming into the office. And then we are adding in different stages of the vessels, we are adding more and more crew members. And we are putting a lot of focus on the safe working environment. And I believe the working environment and the fire safety and everything is going hand in hand. So therefore, we are always trying to minimize all the risks, of course, when we are designing a vessel. So therefore, when we are starting to design a vessel, we are going to the designer, of course, who is designing, and then we are designing the vessels based on our crew wishes, how we want to have it before we are, contacting class and all these parties which needs to be involved. So therefore we are taking it one step further. So now we have a vessel which we want to have. We are agreeing the company, and then we are checking is this allowed and all these things. And we are always implementing good ideas from our crew members. We have a best practice system which is used for everything, sent in more or less something every day. And that can be small adjustments, moving a gauge from there to there and all this. But we are always using this for implementing in our new vessels. And our philosophy during the design related to fire and safety, if is an incident occur, it should be isolated and not spread. And that means that what can spread, what can be the reason for spreading? It can be leaks, it can be, whatever. It can be loose equipment somewhere, it can be. So we are always trying to have big areas in the vessel, which is easy to have clean, and so on. And then, based on that, we are reviewing each area of the vessel when we are designing. And that is, for example, in the engine room, it can be that we don't want to have anything. Of course, we need to have something under the floor, but it should not be any flanges or anything, which means that we need to have the flanges up. And that also which means that we need to have the pump or whatever, valve or whatever, also up. And that is two things which is good. You can easily see if it is leaking, and you can also easily work with the equipment, because then you will get the equipment in the lifting height already. You don't have to go below. So it is both the working environment and fire and safety. And for example, forecast the battery room. When we started, we was thinking, okay, we should have it in the engine room somewhere where it is easy to see it and all these things. But then suddenly one crew member said, if we start a fire, then we want to have the battery room up, because then we can have it isolated and we can fill the room with water. Okay, that is a really good idea. So we lifted up the whole and made a new room for the battery close to the funnel, which is completely isolated. And we can make this room as good as possible for everything. For fire and safety, if the accident occurs, we can fill the room with water very quickly. Yes, and then we have, in the later stage, when we have decided all the equipment and so on board, then we are also taking ashore additional crew members in order to make specific job descriptions, which means for this example, for the second officer LSA, they write exactly with pictures how it looks in our vessels and so on, in order to welcome new officers. And there it is very specific. We welcome you on board. When you come on board, you are a part of the smoke diving group 2, for example. And then when you are coming on board, the first thing you are doing, you are going into the, I will follow you to the fire station, and then we are checking that all equipment, fire suits and everything is working for you. And then we have this Stiftelsens Sjömanshus. We are getting money because our crew members is coming with good ideas. So you can adjust the fire equipment so it suits you when you are coming on board. We are long, we are small, but you can always have it in there for immediate response. So that is good things which is coming from the crew. And they can get some money from Stiftelsens Sjömanshus also. That is also good. We have a lot of crew members who receives money from them. Yes, and then we also have, then we are taking on board, eller ashore, one more person for updating drill scenarios. Maybe we have other type of fuels, methanol and so on. It should be a part of the drill scenarios. All the new thing, batteries, shore power, everything should be a part of the drill scenarios. And all drill scenarios is fixed, so all vessels, if they are similar, of course, they are training according to the same drill scenarios. So we are getting evaluation every month from the drill scenarios, which we can if we are getting some things that this needs to be improved, we can improve it quite quickly on board the vessels, and we can use it for the new building vessels. So that is a way to do that, yes. And also we have seen that because when we come to requirements with regards to fire and so on, should be that two fire suits and so on. We always have for all smoke divers fire suits, and we have that as a part also. We have evaluated which is the best fire suit and so on, so we have that as an owner's delivery instead of getting different in each. And I can say that also if I have time. Do you have these 2 minutes? Yes. Now it was coming. That is also coming from our crew, because we have this pipe trunk, which is also very good for the equipment and so on, and for leaks and everything. And you can also see here we have also these cable trays. But then one crew member was saying the emergency fire pump and bow thruster and so on should not be in this, because if we have a fire inside here, then it will be so. For the emergency fire pump and so on, it's going outside, completely separated. So that is coming from one crew member, 1989, in our vessels. So that is a good thing to use the crew. They are always coming with good ideas. Yes, so I think I'm ready then. Yes. Yes, and our ambition where we are building the vessels is that there should not be any extraordinary job for the crew on board. There should be, we want them to just be relaxed all the time. Okay, thank you.
Thank you, Claes. Amazing to hear. We have a question down in the back. I will start though. It seems like you say you have a higher retention rate, and I can imagine you have a quite low turnover in personnel, change of personnel. And it seems like you've been working like this for a long time. You mentioned 89.
Yeah.
But what would be your recommendation for an operator, for example, who wants to change the culture to have a higher involvement of the crew in the design of ships, for example? What would be the first thing to do?
for us it has been to working with the working environment, because it has two sides, all these things. If you look on a vessel design, then it is normally small areas and so on in order to keep the gross tonnage down. Our gross tonnage by involving the crew is increasing with 2,000 tons. So we need to pay for that every time we are entering to a port for this extra gross tonnage. But working with areas in order to have it clean, and also crew compartments. It should be nice in the living for the crew. But
seems like you care.
areas, yeah.
You care a lot about your crew. That's
yes,
really nice to hear. Seb Corby from Safety.
Thanks. Slightly different question. I'm curious as to how you're getting on with the sales, and how long have you had them? Have you had any issues? Is there any extra maintenance? And when do you think you see the return on the investment?
For the sales, now we are coming into another part. The 26th of November, you have to come to Lighthouse. Then we will explain all this. But it is not related to fire and safety. But it is, yes, it is a quite... if we compare with other things, batteries, shore power, the sales is quite cheap. And the return of investments is quite fast, due to the fact that you are saving consumption. So, a maintenance we can talk about later on. It is not so much.
Any final question from the floor? Let's see, oh, down there, Geir.
Skuld, we are going hand in hand.
Yes, Skuld. Yes, we do. No, very, very interesting, and it's very nice to see. But for those ship owners who say, no, we just built the vessel off the shelf because it's too high of a cost to do these investments, what is your saying on that?
It is not. It is a higher original cost, but we can see it later on the OPEX, on everything. It is less costs. So in the long run, we are earning. We are, yes, in the long run, we are paying extra for every time we enter a harbor. We are losing some cargo capacity due to the crew want to have the methanol on deck instead of engine room. So that is, but in the long run, it is more safe, it is lower cost for maintenance and all these things. So in the long run, then we like to think in the long term.
I can also imagine that if you've been part of the design, you take a stronger ownership, yes, and you care more about, yes, the cleanliness and safety of the ship. So.
We have also later on, when the vessel is ready, then each crew member has a responsible area. Mm-hmm. So one AB is responsible for the top of deck trunk maybe, and one is for accommodation, and one is, yes. So it is all the way.
A very good example about how to work and involve the crew. Thank you very much for Claes for your presentation. Yeah. And I invite our last speaker of today before the panel discussion. It's CFIS Papagiorgio from the Norwegian Maritime Authority, talking about MAS. What is this?
MAS, what it is.
Please introduce yourself and I'll get your presentation.
Thank you very much, Franz. Hello, good afternoon, everyone. My name is CFIS Papagiorgio. I'm a technical coordinator for international work at the Norwegian Maritime Authority. That means that I have the pleasure of working with a lot of different technical subjects. Yeah, just
activating the virus. Okay, perfect.
Yep. Okay, it's installed. And one of them is autonomous ships. Just as a clarification, because I think Franz mentioned before that I'm a coordinator for this work. We, as Norway, we have coordinated the drafting of different chapters of the code, but not the code itself. So I was the coordinator for this particular chapter, right? So first of all, what is an autonomous ship? I mean, we hear about it in the news, and some of you might have seen this, I guess. I mean, this is already operating in Norway, even though, I mean, if you guess right now how many seafarers it has on board, probably you'll get it wrong. We also have this in the Oslo Fjord. And we also have this. This is, as you can see, actually this is going under trials at the moment, and there is no bridge on that one. It's remotely controlled from day one. We also have this project, but then again, you know, we have manufacturers approaching us with this, and this is also within the general category of autonomous ships. And then we also have this. I mean, it even says autonomous on the side. But we also have those. I mean, that's a conventional vessel, right? But it still hit the news. And in the news, this was the ship that first implemented the IMO guidelines on mass trials, so autonomous ship trials. And was this also an autonomous ship? Okay, before I go into where we are at with the MASS code and what it is, MASS stands for Maritime Autonomous Surface Ship, and right now there is extensive work going on at MSC to draft a non-mandatory code, which will be followed by an experience building phase. And at the moment, it will be implemented only for cargo ships. Having said that, in Norway we are currently we do have a project that is, well, it is an autonomous passenger ferry, even though it's not unmanned, but that's a different story. And the other important thing to note about the code itself is that it is supposed to be supplementary to existing rules. So we start off by saying, well, all the existing rules apply. And if we want to have changes or deviations, that will have to go through some sort of alternative design. But it's very different in relation to the alternative design approach that we have had so far, which tackled systems, because now we are talking about the whole ship. At the moment, the plan is to finalize it in 2025. My personal opinion is that we will not manage, and I can tell you why. It has 28 chapters, out of which, well, the chapters that have been finalized are in the single digits, and we have 2 meetings to go, so we'll not finalize it on time. We have 3 parts, and the chapter that is that we are going to talk about today, or that I'm going to talk about, is fire protection, fire detection, fire extinction. I'm going to call it fire protection. It is in part 3, and part 3 is sort of optional, but I'm going to talk about that. So where do we start? I mean, we came up with a question. Okay, we have to draft legislation for autonomous ships. And of course, SOLAS was the basic text. SOLAS has safety objectives and functional requirements. It's easier than other chapters or subjects. But we first had to discuss about what is the level of safety that these ships should have. I mean, very early in the process, there were comments that we received saying, well, if these ships don't have anybody on board, is it okay to let them burn, for example? Yeah, it's. I mean, it was the kind of questions that we had to discuss. Then, as I said before, we had this huge range of different ships. We need to regulate from these ships that have periodically unattended bridge. I mean, according to current rules, that would be. It is included within the scope of the code, but also remotely controlled unmanned ships with a lot of automation. Those are, so we had to draft legislation that would fit both. And then we know that current legislation, it does allow for a lot of alternative design when it comes to fire protection specifically. So what happens if we start automating only different parts of the, let's call it, fire protection function? What then? Is that still under the mass code or not? So the solutions that we have come up, and by the way, this chapter is one of the chapters that has been formally finalized. So I don't expect it to change much until the end, and this was finalized a month ago. First of all, of course, as is very typical with instruments that have been adopted in the last few years at IMO, that we started very early talking about goal-based and goal-based requirements. So what you get is a structure that has functional requirements and expected performances. And at the same time, in relation to the question that I had before, we said, okay, we should have an equivalent level of safety to that expected of conventional ships. Now, that proved to be a bit more difficult, or it does also prove in practice to be a bit more difficult, because what we mean here is not that we will take SOLAS and we will just reapply SOLAS to these ships, but in case the seafarer is not there, then these ships should cater for all those tasks that seafarers do on board that are not regulated. So how do we do that? At the same time, well, not surprising perhaps, no relaxation of existing standards. So nope, those ships are not going to be left to burn. At least not on purpose in any case. They will have equipment trying to prevent that. Mass concept agnostic, so it should include all possible versions or concepts of mass, and that is very often very difficult in the mass code. And then the last thing is that we did go for the option of taking the whole chapter and the whole fire protection as a whole function. And what that means is that we said, okay, you know, if your concept is such that you choose to automate firefighting, then just stick to SOLAS and 1455, so alternative design procedure or whatever alternative design procedure that SOLAS allows you, and don't use the mass code. Because the mass code, what we said is like, we automate the whole function. What it does not cover, this. Do you know, or can you tell what that is? Yes, it is a remote operating center, exactly. And it's one of the existing ones. And the reason that it does not cover the ROCs is because ROCs are typically covered by national legislation, meaning that if a ROC is in Norway, then land-based legislation for fire protection covers the ROC. There are, of course, when it comes to the design of the ROC, when it comes to redundancy, and when it comes to the different needs for it, it's a different question, but fire protection, we don't cover this. So we ended up with quite specific functional requirements and expected performances, and since all of you are experts in fire protection, I thought of really going into some of the details. So first of all, actually before going into the fire protection details, we said that there should be consideration of a fallback state or degraded state. Fallback state for autonomous ships at the moment is, since we actually have normally a human element that is on board for autonomous ships, what we said is that let's put mitigation layers. So for ease of understanding, I would say that fallback state is like added mitigation layers that we have imposed on these ships. So these are considered on how you should handle them. And if you have a normal fire on a ship, what we say is that if it's not on a safety critical equipment, then your ship should not go into one of those mitigation layers, but it should be able to continue its operation. Then we require detection in all spaces with a fire risk. Again, functional requirement in terms of the language. This does not mean all spaces in general. So we said, okay, let's limit it to those with a fire risk. We're still talking about cargo ships. Then we also refer to confirmation. Confirmation is typically something that is not tackled in SOLAS, but as I said before, since we're talking about tasks that the humans normally do, we do require a different source to be able to confirm such fires. That could, again, and still be the human, or it could be a camera, it could be different things. We don't specify. Means to locate the fire so that you can activate the right extinguishing means. You have to still be able to monitor and assess fire growth and firefighting. The way to do that, again, since it is a functional requirement, it's quite free, but we have also indicated that you should be able to measure heat in principle in adjacent spaces, especially, and boundary, so boundary conditions. We also required remote control of all active fire protection measures. Thank you. That means even actively remotely controlling fire dumpers, for example. And everything that could be considered like an active measure that is not passive, you should be able to remotely control it. You might still have humans on board, so take into consideration that you have humans, or you might have, like, for example, maintenance personnel. And like, for example, in the ship that we saw that has no bridge, if there was a need for external fire responders, are we absolutely certain that an intervention would be possible? So this is it in a nutshell, what we have in the fire protection chapter. And I'm just going to briefly talk about like some issues that we see already in the projects, not necessarily with the mass code, because the mass code is not yet implemented, but we are talking right now about a very heavy approval process in general, but also specific to fire protection. We have no standards. It's very difficult sometimes to understand how prescriptive requirements are met or not met. We designers have to do a quite large regulatory gap analysis, and this is it takes time. Obviously, no standards at the moment. I mean, of course, we try to use equipment that exists, but if we are to implement what we wrote in the functional requirements, that will be difficult. And finally, we do have a high uncertainty about the whole implementation of the mass code at the moment. We as Norway intend to implement it as soon as it comes out, but it's that's why we have the experience building phase. And eventually this might be, I don't know if it will be fire safety for the future, as is the title, but perhaps a small part of a greater future. Thank you.
Great. Thank you very much, CFIS. Questions? Mass, is that the future? Apparently so. I have a question, if I may start. No, go ahead. Go ahead.
First.
Okay. Spaces with no fire risk. How do you define that?
As I said, it's a very, at the moment, it's a case-by-case assessment. That the way you do it, we rely very heavily on in the approval process on some documents that are called philosophy documents. So it is up to either the administration or the party that is acting on its behalf doing such an assessment.
Interesting.
Thank you. Alessandro Maccari, RINA Class Society. These kind of vessels, in general, are stretching to the limits the requirements for availability, reliability, redundancy. We have the experience, safe return to port for passenger ships. We have areas that are not fully covered also by international regulations like blackout prevention. And all systems on board, and including the firefighting and fire protection, are somehow based on availability of power and energy on board. So what is your view in terms of complexity? What are the challenges that are specific for mass application, and what could be really the role of automation, also in terms of certification of the automation? Because if everything is related, depending on the automation system of the vessel, then also the certification of the automation system, the type approval, should become a critical aspects in the design and approval. So a general overview based on your experience.
Thank you for that. I mean, these are some great points that you're raising, Alessandro. What I would say, not based on the mass code work, but rather the work that we have been doing on some of the projects, is that we still work a lot with existing systems. So when it comes to certification, we see that it's not yet so difficult because there's not so much like pure automation yet. But at the same time, what we do see as being difficult, as you said, is that when a lot of the other systems are needed to be redundant, when a lot of the other systems, and therefore also to some degree we have some safety critical systems, and how to protect those, like in cases where when you have fire on these areas, how do you make sure that you have redundancy? So I would say that we spent a lot of time in during approval together with the third-party verifier, and I mean it's still the reason that the projects that I referred to in the beginning, that they're still testing and are slowly progressing. I mean, it has been we have been learning a lot, and it's still very difficult. Yes.
Hi. I would dare say that Norway is very much a leader of the autonomous pack, and I think you said that the IMO are the guidelines, or what they're non-mandatory, correct? And you said that Norway is looking to implement as soon as possible. Are you implementing them as a recommendation, or are you looking to take it further straight away?
Our intention is that as soon as they are adopted by IMO, that at that point that we will implement them. I mean, at the moment we do have our national guidelines when it comes to autonomy. By now they are outdated, actually. So we would implement them, but then also we have this North Sea MOU when it comes to autonomy, and we would hope that together with the administrations that are within that MOU, that we will manage to implement the guideline, or the code, sorry, not guidelines, with other countries within the MOU. Yep.
I will ask you a final question. Do you think, like for deep sea shipping, will it happen soon or ever, or what do you think?
Autonomous ships, completely unmanned? Not anytime soon, no. But we might see solutions, more and more solutions being facilitated as like more advanced decision support tools. Right. Like I said before, we have been discussing and the periodically unattended bridge. So solutions like that, we do see. I mean, there is a potential. Still, the legislative framework needs to change slightly to allow for that. But from a technical point of view, that is more feasible than going to the sort of fully unmanned, remotely controlled ship. Yep.
Thank you once again, CFIS.
Thank you.
Thank you. Okay. We're gonna move on with another fika, last one for today, unfortunately. In R that we're hosting. We'll move on with the last question on the Menti as well, before the panel discussion after the coffee break here. So the question is, after an established fire, what would be the best or most useful signatures to monitor, to assist in decision making. So have a thought about that. This will create a word cloud, so we'll see if any of you say the same thing. And we'll meet back here at 4:15. So 4:15. You're welcome back here. So enjoy your fika. Oh. Okay. Yeah, we're... Det är planen. Sorry, the plan is that it will finish at 4:50. Yeah, so 4:50, 4:55.
So if there is anyone going to the airport, you can just let me know. I don't know if you know anyone leaving that.
I don't know. I don't know.
Just let me know if you hear something.
Yeah, yeah.
I've already ordered.
Yeah. 5:05. That should be fine. Okay, everyone, it's time to get started. I love to hear that you have a chit-chatter, a lot of mingling going on. That's great. So, I know you've all been waiting all day for this detection debate or panel discussion. I told them it was going to be a panel discussion, but it might be a debate. We'll see. And you're all welcome to the stage, and I leave the floor to you, Åsa.
Thank you very much. And I can say we are really nervous because of Frans has been saying panel discussion, panel debate in every second sentence. But hopefully it will work quite fine. And you are all very welcome back from the last fika break today. But don't worry, there will be mingling outside with some food and drink after this final panel debate. And I introduced myself in the beginning, but my name is Åsa Burman, for those of you who came later or forgot. And I'm the director of Lighthouse, which is a collaboration platform for research and innovation in the maritime field. And we are also, as Frans has said quite a few times, we're co-organizing and co-paying for this conference. Here is a very nice panel sitting. And Patrik Olander, Vice President Customer Insight at Consilium Marine and Safety. Dawood Zainali, but we shall call him Dave, researcher scientist at Rise Fire Research in Norway. Lisa Gustin, naval architect at Stena Teknik. And finally, Anton Braillard, Head of Energy and Safety Modeling Section, Bureau Veritas. And, yeah. You could have some more of these, actually. Wow. So, I'd like to start with going the panel this way. You can tell me and the audience what is your experience in this field and what is your organization's experience in this field.
Yeah, with detection, I mean, detection.
You can talk about fire safety, and then and fire safety in general and detection specifically.
Fire safety in general, okay.
Very short.
Very short. I don't know where to start. I think it's extremely important. I can tell you that. And as I've seen the last number of years, detection is just a very small part of it, even for us. So that's an important insight for myself and my companies.
So what is your own, have you been working there for a long time? Have you
with Consilium, you mean?
Yeah.
24 plus years, I think.
So
yeah, absolutely. I have been in different positions, different roles, doing different things. So a lot of experience. But what I'm doing now, I would say it's the most exciting, talking to the customers, understand the situations, the challenges, and the possibilities. So a lot of fun.
And does everybody know what Consilium does in here? Or could you give just a short...
Yeah, absolutely. During the years, we have been doing fire and gas detection. Today, we do also a specific visual flame detection. We also work with, as it was called in the Lash Fire project, Digital Fire Central, which we have been doing for 10, 15 years at least, though it's the last number of years that we start to develop that and make it more interactive and smarter.
And you actually participated in a Lighthouse project, AI-based
we
fire
did
safety.
not.
You did not?
It's embarrassed to say this, that we declined and actually said no, though we followed the whole project quite a lot. So we learned a lot from it, absolutely. So, yeah.
Okay, that's good. And Dave?
As established earlier, I'm Dave, a research scientist at Rise Fire Research in Trondheim, Norway. I just actually had a revelation that I have been doing fire safety work from 18 years ago. Since 18 years ago, I started my journey in this field with my bachelor's in fire safety engineering at the Petroleum University of Technology. I realized I like this very much. I'm also a person in a long line of pyromaniacs. So I went to master's. I got a joint degree from the Ghent University in Belgium, Lund University in Sweden, the University of Edinburgh in the UK, which was an international master's in fire safety engineering. From then, I went to Ghent University for a PhD. I did work on flame spread on engineered wood products, including plywood, medium density fiberboards, for example. And I continued from there. I went to France to the University of Lorraine. At LEMTA, which is a part of CNRS, National Research Center in France, I did work on thermal radiation containment, smoke containment, human behavior evacuation modeling, things like that. And after that, I went to Trondheim, where I'm settled now. There we work on many things. To talk about rise fire research a bit, so we do, for example, battery fire tests very regularly. We do methanol, for example, suppression tests according to IMO. For example, we look at water mist nozzles, sprinklers. We do facade testing, larger scale testing. We are invested heavily in hydrogen as well, which was discussed today. But also battery fires specifically. We were part of the Lash Fire project as well, so I was leading the detection package actually in the Lash Fire project during the last 3 years that I was in rise fire research. And I guess I could say a few things about detection.
Yeah,
and
so you will
me.
probably get the possibility later on.
Great.
So, and Lisa Gustin, I heard yesterday that you and Frans have known each other for 15 years, but that was starting with lightweight structures. But now, fire.
Fire, yeah. So I work with Stena, which is a global shipping company with headquarters here in Gothenburg. And we have about 130 vessels. It's mainly tankers and ro-ro ropaxes, but we have some drill ships also. I met the technical division, Stena Teknik, and we deal with concept design for new vessels and also new building projects and conversion projects. Sometimes also investigations and technical matters that is not... it's apart from the daily technical matters dealt with by technical management of the vessels. So a bit more fleet-wide things, and that is how I came into contact with fire safety issues in 2015, post the big ro-ro Ropax fires that year. And we started an internal investigation with targeting our ro-ros and Ropaxes. It was 47 vessels, and I was project manager of that project. I had my previous experience from fire safety at that time was only through some cadet and officer work on board vessels, naval vessels. So I have had my fair share of onboard fire drills, but still it took me quite a while to analyze and deep dive into the systems we have on board our vessels and how our seafarers experience the fire safety work on board and how they react to fires on board. We reached out to RISE at the time also to work together on proper hazards and risk analysis. We found some mitigation measures, and those were implemented in our fleet, for example, water monitors on weather decks and some heat and smoke detection, safe connection of reefers and so on. And those things were then later on studied in various international projects like FireSafe 1 and 2, which you were also involved in, and also through Lash Fire later on. So Stena has been an active partner in those projects over the years. I'm also chairing Interferry Fire Safety Working Group on the side of that. Yeah, that's our fire safety connection.
Thank you.
I think.
And Antoine, last but not least.
Yes. So I'm Antoine Broyard. I started in Bureau Veritas 2006 on alternative design for fire safety. I met people from RISE around the topics of composite structure fires, which is still active topic. I've been asked to get involved into the LNG risks, and I met other people here around this subject with the first retrofit of some ships with LNG. I'm in the research department. The role of our team is to support the Bureau Veritas Classification Society with all the fancy question, new equipments, new fuels, and things like this. So we basically try to answer the question fast, and if we cannot, we build this research project to answer that. And about the car decks fires, we had the opportunity to work with Stena and Rise in the fire safe 1 and 2 lash fire. We continued this topic, and it was interesting to see the development of solutions which were possible for other ships, cargo ships, and we continue with the cargo safe study and try these options, but also other ones. And our role is to evaluate how the risk decrease with the implementation of these systems. So we are dealing with the statistics, the risk models, and the effect of these systems on the risk in the risk models. And before BV, I was doing the start of the fire simulation. So in a French fire laboratory, when we started to avoid a lot of tests and try to have them on a computer or to have more realistic representation of the structure. And fire modeling is my background initially.
Okay, thank you very much. And I will start with a question that I did not tell you yesterday. But I think somebody in this room might be able to answer. Where are the fires most common on board? I think I've heard a lot today, but is it cargo? Is it in the machine room? Or is it anywhere else?
Machinery. 50%, I think.
Okay, thank you. Good to know. And the next topic was about monitoring, continuous monitoring after a confirmed fire. And I have not spent much time on ships, but I spent a lot of time in process industry and in control rooms where there are alarms, lots of alarms from different types, and that's the same, I think, on the bridge or in the machine room. And what do you think is most useful to detect or to know how to handle the fire? How do you know? For instance, is it a false alarm? What should we do?
Yeah.
What is really happening?
I mean, continuous monitoring post the detection. For us, it's really important to have some heat information to be able to, because especially on the car decks, because we have our fixed extinguishing system or suppression system, and it can be used in only, let's say, parts of the cargo hold. It's not enough to cover the full cargo hold. So to understand where the heat is spreading, so that you can sort of use tactically your fixed suppression system, that is one of the important parts. And of course, if you have video and it's not covered by smoke, then that's also good information as well.
Okay, Dave?
I think you touched a very sensitive nerve because not a lot is discussed about detection, continuous detection after the fire has been detected. We look at, for example, time to detection of the fire, and we evaluate systems for detection of fire for that. So, this system detected the fire this early or that late. But we don't talk about the useful information that you can get from the fire spread, for example, or where it's going. And that continuous detection is just as useful as the initial detection. Of course, you want the early detection, but you also want continuous information, for example, regarding the location of the fire, the source of the fire, and how it's spreading. So these three information pieces, in my opinion, are the most important things that you want to know. Where is the fire, what is the source, and where is it going? What can I do based on these three pieces of information?
Would you like to add something to that, Patrick?
Absolutely. as said, monitoring temperature I think is very important, as well as smoke. Doing that in a very early stage, long before you actually get a detection or an alarm, as you usually get from the EN54 approved systems. Following up what happens after that, even if it's early and not yet an alarm, or even if you get to the alarm level, following the spread, see what is going on. Also monitoring if the fire is quite large or grown big, so to say, monitor the areas close to where the fire is. Or as was talking about earlier here, the Scandica fire, and measuring temperatures and smoke on the deck above, perhaps. And this can actually be done today in a fairly easy way with existing equipment. So you add some AI software on top of it, and you can monitor small changes. So that, I would say, will give a good overview of what is going on, that you can monitor the situation.
Would you like to add something, Anton?
Yes, two ideas, especially with the electrical vehicles that can restart after a while. So it's important to have a system that is able to monitor things after heat damage, potentially. So something that can resist the fire and monitor the temperature after the first detection. That would be interesting. And also I had the same as for the RoRo deck in cargo holds where you have the CO2. You have a limited amount of CO2, and you can release it in a number of shots, and you could monitor what does the first shot and then adapt to keep a reserve of CO2 and not to take everything in the first place.
I think there was a question in Menti about, and here it is. And you can see it here, temperature, nature of fire, video. Do you agree to this?
Temperature for sure.
Temperature for sure,
yeah.
and that's the largest. So
yeah, I mean temperature you're going to get from anything that starts a fire, and quite early.
So you agree with the audience then?
Nature.
I voted for that one.
If you want to move to the debate stage of the session, I would say temperature is a confusing and kind of bulk parameter. When you say temperature, usually people talk about surface temperatures or the temperatures at certain locations. It's very local information. It's very difficult if you put a thermocouple in the air. You measure, you don't know what you're measuring or where it is and how useful it is. So depending on where the fire is, you could be getting very useless information that could be very misleading. So if the thermocouple is in the smoke layer or not, you would see differences, or whether it is shielded. You would get different results, and then you may take wrong decisions.
But I think didn't you all agree? I thought you almost all agreed on that. When you're following, when you're monitoring what is really happening, then you use temperature, don't you?
Well, I don't have anything against temperature. I'm just saying that it's a local measurement usually, and if you have the temperature in the right place, of course, that's very critical information. I would like to know if there's a fire room, what is the temperature in the smoke layer, for example, or what is the temperature on the deck above. When is it the time that I should be worried about certain things? But of course, I'm just saying that where you're making this measurement and what weight you're giving to this parameter is very important to your decision making. And you should be aware of that. So just don't blindly make decisions just because you have one piece of information.
Okay.
So the more sensors, for example, you have, the better decisions you can make.
Okay, and we're talking about normal or what we're used to, fires that we are a little more used to. But what about battery rooms? What should be monitored there?
The BMS system, if there is one. Goes the same with the cars, I would say. Then I think there must be, I would say, created a standard. I thought about that earlier. I mean, BMS, sure, get the data, but it has to be the same data no matter what kind of systems is or car that is connected. Otherwise, that's going to be misleading. You know, if there's coming one brand of car sends you some data and another car sends you some other data. So that must be exactly the same, of course. So a fixed battery system on board the vessel, or if it's going to be a car, relevant data from the BMS It's going to be crucial. I tried myself and talked to one of the car manufacturers. That's a challenge, I can tell. They didn't see the benefit of doing this, so this must be, this is a discussion we need to start now, if it haven't already been started, so to speak. I think that's a fairly long journey to get them on board.
Okay, so that was the cars. But we should talk about the battery rooms or the batteries for the ship. What should be monitored there? Like, for instance, Klaus Möller, who has just left, I think, but he said they have the batteries in its own room. They can fill it up with water, but what do you think they're measuring?
Do you mean post-detection? Are we still at post-detection?
Yeah.
Okay. Yeah. I guess heat again. But, I mean, if you have post-detection in the battery room, then you already must have deployed your fixed systems to that, I guess. So...
Or prior to actually detecting, what will you use to detect?
I think what we heard earlier today was local detection on, let's say, the battery packs and the battery units. But for the room, that is typically we can have normal fires, so we need to keep the normal heat and smoke, and possibly also gas if that would add to it. But at least heat and smoke for me is important.
We actually got a question from the audience that was sent in prior to this, and it was about segregation of when batteries are shipped as cargo, if they should be segregated from other dangerous goods, or if it should be just handled as regular dangerous goods. Was that correctly understood? Yeah?
It would be helpful if you ask who should answer.
Who knows? Because I already talked to Lisa and she's not an expert on containers, so I'm not asking her. So,
from my point of view, of course, you don't want to have different dangerous goods piled up together, no matter what they are. I think that's a common policy. But sometimes you have limitations. For example, certain dangerous goods, if there are too many of them, what do you do with them? Usually you want to put, for example, certain stuff on the weather deck and try to segregate them from other things. But there are always limitations. But if possible, definitely I support segregation and separation of the dangerous goods.
I just want to add, I mean, when we talk cargo separation, you don't mean space in between, you mean rather to put other units in between, like we do with the dangerous goods code. And I think batteries is already covered, but transport of batteries is already covered in the dangerous goods code, as I understand.
When they are declared.
When they are declared,
exactly.
So it's.
But otherwise, you can't spread them anyway if it's not. If you don't know you have them.
So it was a question this morning on cargo safe, how this was considered. There are so many undeclared incidents that we didn't take into account the fact that they would be segregated. I mean, this incident can happen everywhere on the ship, at least in the risk model. And yes, declaration, especially of batteries, is an issue because they are everywhere now in any product manufactured and coming in Western countries and everywhere. So, yeah, can really difficult to be strict on the segregation on one side and not to declare on the other side. It's too easy, and that would push things to be undeclared also.
We've done a study on that, misdeclared, quite a few misdeclared dangerous goods. We had a question, didn't we? Meant a question about the most promising technology for early detection of BV fires, since we're on this topic. And I think I heard somebody say BMS before.
BMS, absolutely. So I've already started that in a way. I see that as number one, you know, but it's a bit of a journey, I would say, to get there, to get car manufacturer, get the standard in place and all that. As I said, one of the car manufacturers said, no, why would I do that? What's the benefit for me? So I think there's a lot of things that we don't understand from their perspective. Their brand name, protecting the brand name and stuff like that, commercial reasons. So that's going to be number one. If we're not able to connect to the BMS system, which can be done wirelessly, of course, and that's the only way to do it, basically. But using existing infrastructure could be done, which is make it very easy, so to say. Otherwise, again, temperature, either with thermal imaging cameras or cheap wireless sensors that you could put perhaps underneath the car and so on. There's going to be some logistic challenges with that, of course, but then you can, I mean, with the EV cars, protect the battery or detect what is going on there as well. I don't think we shall forget petrol and diesel cars neither. With a regular 12-volt battery that they have, they can also cause a fire. So even new cars, so to say. And they are pretty smart nowadays, I think. So one could probably connect those as well and get some relevant data.
I have another question here, also sent in prior to this. And if any of you can answer, or in the audience, it's fine. Is there any information regarding a study about using cryogenic gas to stop or to slow down the thermal runway?
Maybe the audience know.
Yeah, maybe the audience know that better, perhaps. Not my expertise.
Have to answer this ask this question somewhere else. Lena. Okay. Or do you want to say something, Frans?
I spoke to one of our researchers, and he said he wasn't familiar with any such study. They could be possibly affecting or lowering the possibility for an internal short circuit, but he's just guessing. But also, if you lower the temperature too much, it could cause harm. So you have to follow the manufacturer's specifications. But it's definitely an area that we would like to look further into.
Okay. Thank you.
It is technically possible to use that solution according to, for example, some of the diagrams that show the rate of heating and the rate of cooling. If you cool the casing enough, you would definitely circumvent the problem. So it's technically viable, but whether it is commercially possible, it's questionable.
Okay, maybe next year, or I mean, the conference in 2026. Yeah. Let's talk a little about new fuels. We've talked about them a little already today, and how do the new types of fuel in general affect the need for dedication? And now I'm not talking about cars, I think. I'm talking about the new fuels that are used on the ship.
Gas detection is important.
Gas detection.
More than regular fire detection, so to say, with smoke, heat and flame. Gas detection is going to be very important for any of these. Hydrogen, ammonia, battery, methanol and so on. When I spoke to my product line manager about gas, he said the technology is there, the regulation is behind, so to say, quite a lot. So yeah.
So to detect that it's actually leaking, or detect that it's actually
yeah, I mean, detect leakage from any of these tanks or pipes going to the engine and in the ambient atmosphere in the engine room and so on. So I mean, this is what we have been doing with LNG since that had been used for some years, but similar with the other alternative fuels. But so the technology is there, I would say, more or less, some adoptions, but the regulations are not there yet.
Do you agree all with this?
I tend to disagree.
I'm thinking about ammonia. Is
If you talk about detection, usually people talk about early detection. That is that can contribute to preventative measures and taking measures to solve this, address the situation. For gases, you can detect them early. There are solutions. But for battery, it's very difficult to detect a fire or the ensuing problem early enough for you to be able to address it. For example, if you are talking about hydrogen, people are putting it up there on the stake, but there is no good reason for that. You can detect small leaks very easily, and then you have time to address them. Whereas for battery, you're not going to see anything until it's already too late. Usually in battery fires, you are seeing the smoke, and the fire is already late. So I would put the battery on top of this list for detection. Because what is detection? The useful detection is the kind of information that can give you insight to prevent something or to take actions early on. From that point of view, batteries are much more difficult to deal with. For example, in cars, they are hidden. Thermal imaging is not going to help you. The only useful information you get from that is when the fire is already external. So I'm 100% behind the battery management system or the BMS, giving information which is highly central to the problem and can give you early warning. That's the kind of detection that is useful. Any other detection mechanism or solution would be addressing the symptoms but not the disease. And even before that, I would say, so you start from the manufacturer.
But if we think of this as fuels for the ship, because we can talk about cars all the time. This is actually
it is still the same problem, as I said.
Yeah. But if we talk about, and we've spoken a lot about batteries, so could we, if we talk about the other, actually the fuels, hydrogen, ammonia, methanol, LNG, how do we?
I still stick to my point that the hydrogen and ammonia can be detected early enough, but not batteries.
And do you, with just gas detection, heat, smoke detection?
So, in terms of regulation, there are 3 issues. So, to detect the leak without fire necessarily, to detect the fire of one of these products, so you have to adapt the detectors to that type of fire. Methanol flame, don't emit in the same range as conventional hydrocarbon fires. The same for hydrogen. There is not so much heat radiated, so there are some sensors that will not work. And you also have to detect fires which are not linked with the product, but you want to protect the product from the fire, which is a conventional fire. So you have to think about 3 detection functions to tick with your system. And in the regulation, we try to have the 3. And when in the discussion, it's important to, when we speak about this in the risk assessment or something, to have these 3 aspects in mind. To protect these gases, because they are very dangerous, and to detect them when they are leaking, and to detect their flames when they are leaking, burning at the same time.
And what about ammonia? Ammonia is a very toxic gas.
Yes, but it's not fire.
No, but if we extend a little outside of fire.
Yeah. It will not burn easily, so I guess it will be detected by the gas detection in the first place. So it's myself speaking. It's not BV, but I would not expect to detect a fire of ammonia, but you will detect the ammonia first. And to ignite ammonia, you need a pilot fuel, and you need a fire of something else in the area. So you would have needed to detect this fire in the first place. Maybe I'm wrong, but...
And maybe if you want to know more, I think Anna knows a lot, because she's just conducted a study called Safety of Ammonia Aboard. So maybe you should answer this question.
May
Lisa.
I add some? Yeah.
Yes, sure.
Okay, so from a user perspective, I just want to make a wish. Like these systems, when we have them and we start to get more complex room situations with various kinds of fuels and carbon, and perhaps also at the same time, we need detection that works, of course, and preferably like a simple system, like something that can do it all, but I know that's maybe impossible. But something that is simple when we try to develop this, and also the presentation of it, because someone will need to receive this message. And for me and for my crew, it's not really detected until someone has actually understood what is here. So it doesn't. We're not helped by just having an alarm. Like, we need to also get some information. What is leaking here? That kind of presentation is really crucial also for us to take actions. So I just want to add that as a wish for anyone who's developing this.
To clarify, the methanol and hydrogen, as you mentioned, they don't emit that much infrared radiation, but for detection, you have other very efficient methods of detection, including UV-IR flame wavelength detectors that pick up the ratio between ultraviolet and infrared radiation, and they can respond within milliseconds. If there are hydrogen flames, for example, or methanol flames. In terms of leaks without flames, you have sound detections, for example, if you have high pressure systems. So I would say you have some options there, but for battery we are still lacking. I think the most challenge is there.
Now we have I think maybe 5 minutes left, and we've all been, you all heard about this panel debate and about everything will be clear with detection and whatnot. So do we have any questions here in the audience? Not a single one. Okay, so there's Seb who wants to ask a question. And where's the microphone?
I've noticed I get named now. Sorry. I'm interested in Consilium's, what your view is on the latest and greatest in terms of, well, all of it, to be honest, but taking gas detection, because we're talking a lot about gas detection, but you've got your really traditional gas sensors that have been around for decades. You then got these new IoT devices that are sensing all sorts of things, and there's a Bosch sensor that's kind of the latest and greatest off the shelf, but other people are developing their own stuff. So as a technology integrator, I hope I'm not dropping you in this. I'm not trying to. What's your view on all of this stuff?
All of it. Maybe I should start with what you actually mentioned earlier, and that is nanotubes and eNOS. This is something that we are looking into. We do not have a product as of yet, but I strongly believe in that technology. So that will be soon the latest and greatest, I would say. Yeah, when it comes to gas, there are other sensors and so on, but this is something that we really would like to explore further and see what can be done with that, for sure. It's very promising technology.
Do you agree?
Yes, but I just keep thinking that we are addressing the symptoms, not the disease. The fact that for all of these, especially the batteries, for example, you need different layers of protection, not just relying on the detection of a system on board that will tell you the ultimate event happening. So from early the development phase, you have people and layers of protection that could help you prevent the final outcome. For example, in terms of batteries, you have the manufacturers developing stuff, BMS. You can have the screening of cargo before going on board. So that's the second layer. And then on board, you can have connection between the BMS and the ship. And then the final layer, you have other sorts of detection systems that hopefully tell you about the ultimate events and accidents that are happening. In terms of gas, for example, and liquid fuels, there's not much development work that is required, so the initial layers are missing, other than the technological culture that should exist. For example, for hydrogen, there has been a culture of safety because of its unique properties, but for others, there is a lack of development.
Okay, thank you. Do we have any further questions? Yeah. CFIS. He thinks we named this conference after him, actually. You did, Frans? Ah, that's very nice of you.
That's a nice start. Thank you. I just, if you would have a wish list towards regulators, what would be
the number one thing that you would like regulators to prioritize on in the next, and I'm talking about IMO work, so in the next 2 meetings, okay, we would like this to be the priority.
Antoine?
I don't give the. I'm the regulator. No. To be honest, we have to be in our company. We cannot select one to be priority.
Okay, Lisa, what would you like to say?
No, I have no good answer to this question. Sorry.
If I stick to my ranking of the challenging options, batteries, I would say that we have to regulate the production of battery management systems and the standards. What do we mean with the battery management system? Is it just there to make it efficient for the battery to function, or is it there also to provide valuable information to the ship, for fire safety and other things, and what specific parameters we need, and what should be the protocols of connection between the battery systems and the ships?
What do you say?
We need very central information. That's the only way to answer the real problem.
As I said before also, and I agree with you definitely, that finding a standard for the BMS systems and also the safety purpose of it then, and not just the regular operation.
Do you have a suggestion of your own? No. There's another... Okay.
I have a question to Consilium. I'm also perhaps equally strong believer in nanotechnology, in the detection. As we all know, the international regulations, IMO, will not catch up with the technology perhaps within the next, well, the fastest was ISPS code, and that was 4 years. With this kind of technology, I don't think it will be less than 10. What would be your proposal if you developed a product? And I would like to hear a common answer to that question from Stena. Let's say Consilium will validate the product. It will be effective. Would you go voluntarily on, we call it in Ajax, above and beyond requirements to install it?
That's for me, I guess.
I think so.
Sometimes we do, sometimes we don't. That's the truth, and it depends on the application, I would say, and the risk we think we're facing.
It will not cost equivalent of a case of Coca-Cola, obviously. It will be expensive, but considering the increased risks of getting older and older, not only electric vehicles, but also hybrid. 22 years is since the first Prius went on the market.
Do you have a last question, because we need to end?
Yes,
so.
I would like to invite both Consilium and Stena to explore, or maybe send us a message. We've got a scheme. It's called
you can take it outside
certification
when we're mingling,
technology
please.
Qualification.
Yeah, but you can. You will be drinking wine and things like that outside, and then you can talk about that. Because we had one last question, and then I think Frans would like to end the day. So, very short.
I just had a last comment on that. So if I would choose one where IMO just focus on the seafarers and their skills and knowledge for these alternative fuels, training and education. Thanks.
And then I would like to say thank you very much to this very nice panel. And also to the very nice audience.
Yes, thank you to the audience for all the questions and your interactions today. So, yeah, you can stay here because I'm just going to wrap it up real quick. Would you like to come forward? I would like to thank you again, and the Lighthouse, you, not as a person, but the Swedish Mercantile Marine Foundation for the funding this event.
You can thank me as a person.
I can thank you as a person as well. You're great, Åsa.
Thank you very much.
For hosting the panel and for co-organizing this event and for the funding. It would have been done without you. And we're hoping, let's see if this works. Yes, we'll see about the 5th International Conference on Fire Safety at Sea. Where it will be organized, I kept your logos on this picture, just hoping that you might want to fund it
Depends
again.
on where you go. It has to be very nice.
I'm thinking Hawaii. Yeah.
And the foundation, Stiftelsen, we would like to thank the RISE Lighthouse for this very, very interesting conference. It's been a very, very nice day. And we are looking forward to be part of future events like this. So thank you very much.
Thank you. And I know what you're all thinking, the big elephant in the room. Behind every great conference, there is a woman. So Anna, welcome to the stage.
Yeah.
So Anna has not been my assistant in this. She has been the project leader, and I've just been tagging along for the ride. So she's done almost all the work. Thank you so much, Anna, for everything you've done for this conference.
And since we're thanking, could I also thank maybe my colleagues, Lasse, that is actually standing behind the camera, making sure that everyone can see this now and forever. And Caroline, I think she has maybe had to leave, but she has been part of the coordination work as well.
And thanks to all of you that has make this conference really good, alive, live, present, and asking good questions during the mingle and the question sessions. So thank you, and please come with ideas for the next conference.
Yes. It's called in Swedish P3-övergång, a transition according to P3 radio program. Because, as you can see, we would be very happy for your feedback. What would you like to see more or less of at the next CFIS? Of course, if you thought everything was just perfect, you're more than welcome to write that as well. But I'll put this down and I'll keep it open for the whole mingling. And now you're most welcome for a closing drink for like an hour-ish or so in the restaurant. But two pieces of information, all the presentations, we hope that all the presenters will allow us to publish them at the Lash Fire website. The recording of this event will be published at the Lighthouse website. We'll link in between, of course. And also, for those of you staying overnight at the Gothia Tower and would like to just go out with some colleagues from the industry tonight, I had a suggestion from Robert Scott to meet up at the Gothia Tower 1 at 7:30. So he'll be there. This is the guy you should look for. He'll be there from like 7:15 if you want to join him for dinner or something. At 7:30, meeting up in the Gothia Tower number 1. So this is not the end. We'll see you again, and let's get some wine, I guess. Yeah. Thank you for coming.
Thank you.
Aha, tack så mycket, tack så mycket.
I just have to head out, so thank you very much.
Thank you so much for coming. You have a very good presentation.